Hello there and welcome to Solaris 360 once again. I hope the previous video was useful, and as promised in our last video, in this second video I am going to cover the current flow in rooftop solar power system in different conditions. So let us try to understand the flow of current in different cases. In our house, without solar system, there is no solar panel or inverter or solar meter, so the current flows only in one direction from utility grid to the electrical panel or distribution panel and to our house. But in case of solar plant, we have an extra line from solar panel to DC to AC inverter and electrical panel. So let us understand that, and with three different examples. So first case is when both solar power and grid power is available, and next two cases are when one of them is not available. So let's talk about the first case first, when both the power sources are available. Here again we have two cases. So when power requirement is more than solar generation, and when the power requirement is less than solar generation. Let's consider case 1a during daytime, when your power generation is more than your electric load. Let's say you have installed solar plant of 1.2 kilowatt and you are sitting in your room with 1 ton AC running and few other things running like TV and fridge. So your total load right now is, let's say, 3.2 kilowatt. So first of all the powers will be drawn from solar plant and the remaining will be drawn from the utility grid. So 3.2 minus 1.2 is 2.0. So that means that your total load requirement from utility grid has been reduced to 2.0. Earlier it was 3.2. Now since you have installed solar plant of 1.2 kilowatt, it has come down to 2.0 kilowatt. So at the distribution panel, both these power supplies will get merged to supply the power of 3.2 kilowatt here at distribution panel. So that means that you will be paying less for your electricity bills. Earlier you had to pay for 3.2 kilowatt of load. Now you are only paying for 2.0 kilowatt of load. Now let's consider case B, when the power requirement is less than your solar generation. So again, your solar power plant is of size 1.2 kilowatt, and now you have switched off your AC and all the other equipment. So the current load is, let's say, 0.8 kilowatt, maybe a few fans and few tube lights. So your current requirement is only 0.8 kilowatt, but we are generating about 1.2 kilowatt at any moment. So what will happen, from 1.2, your 0.8 will be drawn by your housing load, and remaining 0.4 kilowatt, that is 1.2 minus 0.8, so 0.4 kilowatt will go to the utility grid. That is the excess power generation by your solar plant. So that will be exported to the discom or torrent power, GEB, DGVCL, whatever you have. Yes, you can see the difference in current flow. Here net meter will measure the current flowing in opposite direction. So here earlier, in case A, the current was flowing from utility grid to your distribution panel. Now in case B, your current is flowing in opposite direction. The net meter will measure the current flowing in opposite direction separately under exported reading. So in this case, we are not taking any power from the grid, but instead we are exporting. So this exported power can be used in future when we need power from the grid, like in case A. Let's move on to next case number 2, at night or during cloudy environment, or when the solar power generation is 0. So in this case there is no generation. your load is still pointed. So all the current, all the power will be drawn from the utility grid. So there is no uh, power drawn from the solar power plant. So this is like your normal connection. So all the power imported from your uh, distribution company. No power is drawn from solar. This is zero export and all import. You are not exporting any power to the grid. All the required units will be imported from grid. Now let's move on to the third case. In case of power cut. So in case of power cut during daytime when the solar power generation is on, the plant can generate about 1.2 kilowatt of energy. But since there is a power cut, in that case your inverter will automatically shut down the conversion of DC power to AC power. So in short, your solar plant will be shut down. That is for safety issue. So in that case you will not get any electricity, you will not get any power. There will be no power imported from your discom, and there will be no power drawn from your solar plant, even though your plant is capable of generating the power. This is for safety of the grid. This doesn't happen in the hybrid plants, as the excess power can be stored in the battery without sending it to the grid, but it is again expensive. So that's the end of the second video on current flow. The next video will be on net metering, where I'll explain the whole billing system in net metering with an example. I hope that the video was useful, and your comments and suggestions are always appreciated. You can write your suggestions, query to us anywhere on Facebook or YouTube or even WhatsApp. You can even call or WhatsApp us at 9998117531. To subscribe our YouTube channel, you can always click on the link given below. Our email is info@solaris360.com, and if you like the video, please share with your friends. Thank you. Have a good day.